Hello everyone, my name is Michaela Relford. I'm a second-year mechanical engineering major at the Georgia Institute of Technology, or Georgia Tech. Today I'm going to be discussing Lab 1 for my Physics 2212 class. This lab goes over the electric force, electric field, and electrical charge. For this lab, we use charge strips of clear Scotch tape in order to observe interactions between objects of the same charge, opposite charge, and of neutral charge. Using the three equations that are on screen now, we were able to determine the magnitude of the charge of the tape, whether that tape was positively or negatively charged, and the ratio of atoms that lost or gained electrons in order for the tape to be charged. So, let's get into the experiment, shall we? In this experiment, we charged pieces of tape by ripping them off of other pieces of tape, and observed interactions between the tape and other objects of various charge. As you can see by the data table that's on screen now, the tape repelled other pieces of tape, which makes sense as we can assume that they are equally charged. The tape attracted neutral objects, which we learned is because it induces a dipole in the neutral objects, which means that charged objects will always attract neutral objects. The tape was repelled by a negatively charged pen, so we can assume that the tape is positively charged. So great, we know that the tape is positively charged. But what is the charge of the tape? In coulombs, I mean. If we set up the tape vertically such that they're perpendicular to one another, we can use the force of gravity to find the electric force, set these equal to each other, and solve for charge, as long as we know the mass of the tape and the distance between the two pieces of tape when they start to repel each other. As you can see at the top of my page, I have determined the direction of the XYZ axis for my calculations. I've also sketched the experiment and included constants such as the distance between the two pieces of tape and the mass of the tape. I have also drawn a free body diagram which demonstrates that the electric force is equal and opposite to the force of gravity. Right now I'm going ahead and writing down the equations for the electric force and for the force of gravity. As you can see in my equation for the electric force, I have written Q sub B squared. This is because we can assume that the charges between the two pieces of tape are the same. We can solve for the magnitude of the force of gravity by multiplying the mass of the tape, which is 0.002 kilograms, times the acceleration of gravity on Earth, which is 9.81 meters per second squared, to get the force 0.01962 newtons. We can set this value equal to the electric force, and solve for Q sub B, which gives us the square root of 4 pi epsilon naught d squared times the force of gravity, which we can solve for in order to get Q sub B, which is the charge of tape B, is equal to 2.52 times 10 to the minus 7 coulombs. Since we know that the tape is positively charged, that means that there must be a deficiency in electrons. We can solve for this deficiency by dividing the charge of the tape by the charge of electrons. After performing this calculation, we can determine that the electron deficiency is 1.58 times 10 to the 12th. We can start to find the ratio of atoms that gave up electrons by starting with the dimensions of the tape. We can find the area of the tape, which is 0.004 meters squared, and the area of an atom that we're using is 1 times 10 to the minus 20 meters squared. By dividing these two quantities, we make the estimation that there are 4 times 10 to the 17 atoms in the strips of tape. This is an estimation, of course, this isn't exact. We can divide the deficient electrons by the number of atoms to determine that the ratio of deficient electrons to atoms is 3.95 times 10 to the minus 6. Now that we have a ton of data, we can model this in VPython. We'll just use GlowScript for this. As you can see, my calculations in GlowScript support the calculations that I made by hand for this experiment. The magnitudes of the two forces are equal to each other. Here, the red dot is meant to model tape B as a point charge, and the blue dot is meant to model tape A as a point charge. The green arrow is the electric force acting on tape B, and the orange arrow is the force of gravity acting on tape B. If electrons had a positive charge and protons had a negative charge, the sign that we use in the equations would change. The magnitude of the two charges would be exactly the same, and the interactions that we witness would be exactly the same. But to be completely honest, the calculations would suck. I make a lot of sign errors if I'm being honest. While performing this experiment, we found that it was really important to handle the pieces of tape as carefully as possible because we didn't want them to lose their charge. As you can see in the videos that I'm sharing now, the experiments didn't really work. This is because the tape had become attracted to the neutral books that it was standing on, or attracted to my hand, and it lost all of its charge. I had to recharge it in order for the experiment to actually work. In conclusion, we were able to use a few simple calculations in addition to a few simplifying assumptions, including having air resistance be negligible and considering the two tapes to be point charges to determine the charge of the tape in addition to a few related data points. So thank you for listening to my presentation, and I hope you have a wonderful day.